Hello, folks. So, this is part two of my interview experience at Capillary Technologies. I interviewed with them a few days ago. I interviewed with them on June 4th and June 5th. I realized I actually missed to tell some stuff. So, some of the things that I didn't mention, I'm going to tell it as more details, right? One of the things was in the fourth round, or actually not the fourth round. I think actually the fourth round with Pallav. The question around how do you do an upgrade? Let's say for Redis from one version to another version. I mentioned that you find differences and all. I mentioned that features, API, and whatnot. The thing is, I also told it's important to test things, and especially when you roll out. So different kinds of tests, right? You have integration tests where you check it with the application. You have probably some functional tests just at the Redis level if you're upgrading a Redis, or if you're upgrading some other database or data system, then you just run some functional tests on it to understand the features that you use are working on it and whatnot, and its intended output is coming up. And so different kinds of tests, different levels of tests, right? And once you roll out, so in R&D itself, you can actually do a lot of testing, and during R&D itself, you can look at metrics, and even when you roll out, like deploy it to wherever you need to deploy it, you can start looking at metrics. So monitoring, alerting, observability are all very important. So keep an eye out for alerts. So ensure that your alerts are actually set up properly, and you review the alerts. Actually, Palla was asking me, did you review different kinds of alerts? I think Palla or Deepak, I forgot. They're asking when we set up alerts using Prometheus Grafana in my previous companies, say in ThoughtWorks, we are using Prometheus Grafana in one of the projects. So he was asking how often did you review your metrics and your alerting and whatnot, and change it and whatnot, right? And about OKRs and all that. So I mentioned that we didn't change it much really. So yeah. So I was telling, like, yeah, I mean, in this case, look at metrics. What the metrics like failed queries. Let's say it's a Redis, and some queries failed for some reason, or some specific types of queries failed and all that. So look at the specific types of failures. Let's say in 100 requests, 10 requests failed, and the other 90 passed. Try to understand and find some patterns in those 10 requests. Maybe it's possible that those 10 requests are some specific kind of request. So, which means that a specific kind of request completely gets failed. It fails compared to other kinds of requests, in which case you have to actually look at it and understand what caused the failure. So you can also look at stuff like network issues. So what caused network issues and all that. First, you need metrics. So look at networking metrics like bytes in and bytes out. So how much bytes is coming in into the Redis, how much bytes is going out of the Redis and whatnot. And yeah, I was talking about how you can do a smooth rollout instead of rolling out to everyone at once. Like you have 100 Redis instances, then you just completely replace those 100 with another 100 and get rid of the 100. No. Instead, you do a smooth rollout, you replace some of them with a new one and whatnot. And also with zero downtime. So, if possible, which is usually possible. If it's not, then yeah, zero downtime. Higher, it's a higher cost, but worth the cost, right? Of doing zero downtime. So, or else find out maintenance time, right? And also inform developers, customers, or clients, and all users through UI, email communications, etc. Right? So yeah, and of course, do the rollout along with the teams. So I said, like, here you can actually see, keep the corresponding team and developers in the loop always. It's their service or product, and also maybe keep the customers or clients or users in the loop when things are being done, in case it will cause downtime or functioning, reduced functioning or inconsistent functioning of the service or product, right? And yeah, I spoke about smooth rollouts. So first probably start with less critical environments like developers environment or staging environment and QA environment, and then go ahead with other environments like production. And even when you do a particular environment, let's say staging or even production, start with less critical services and products, right? And you know uh, Less critical services or products which use the Redis, and if that Redis goes down, then less critical services or products and less critical data systems, right? uh, Instances of data systems. So you will know what is critical and what is not critical, uh, and then more, and then two more critical. Um, yeah, first start with less critical environments or non-critical environments, then go with non-critical services or products, and go with non-critical instances of the data systems, right? And then slowly increase the criticality and start doing things and do a smooth rollout, and always keep your alerts on and keep an eye out by ensuring that you get automated alerts, and you also ensure that you can do a quick rollback, um, and also ensure disaster recovery, like you don't lose any data, uh, right? Depending on the kind of data system, right? Sometimes you can lose data like say cache and all, but yeah, you have to be careful. So sometimes if you lose the cache, the service or product becomes slower. So that's also something that can affect the users, the clients, and the customers. So what else did I say? I think I was also talking about. Uh, yeah, I think that's it. But and the things that I missed, talking about the costs of the upgrade and the return of investment. Basically, the other thoughts about benefits of upgrades, which I missed to say. So I didn't say that, like the ability to upgrade is if necessary. So you should have the ability to upgrade, right? If necessary, for example, due to security issues, security fixes, bug fixes, performance issues, and performance fixes, right? So even in your metrics, you should actually keep track of the performance and all. Look at performance metrics and all, right? Look at correctness metrics, right? That the system is correctly giving the output and all that, and behaving correctly. So, and also if you need new features that the developers want, because they want their service or product to do something, because the customer or client or user wants it and whatnot, right? So sometimes the difference or distance between the source version and the target version can be too big. For example, 1.0 to say 4.0 or 5.0, right? That's a big change. Considering semantic versioning, 1.0 to 5.0 is like a big jump. So, and if you want to do that upgrade, it's called jump upgrade. Do you directly upgrade to 5.0, or do you go from 1.0 to 2.0 or 1.0 to 1.1, 1.2, and so on? And like, how can you upgrade? If you need to do jump upgrades or step upgrades and whatnot, what is the procedure, right? So if the difference or the distance between the source version and target version is too big, and it can be too big, then it's sometimes impossible or very hard to do skip upgrades. That is to directly upgrade from the source version to the target version. So in such cases, it's better to do step upgrades, and of course follow the upgrade guides by the software. So doing all the step upgrades at once can be too much. So doing upgrades often can help. Like doing upgrades, let's say you have 1.0. If you upgrade often, let's say to 1.1, 1.2, though you don't need some of them, at some point, let's say they find out that 1.0 or 1.9 has some security issue and it was fixed in 1.9.1, um, or there is a security issue which is there from 1.0 to 1.9 and it was fixed in 1.9.1, and it is not available in say 1.0.1, then you will still have to do the upgrade. um, but yeah, ideally the software should provide patch upgrades and patch fixes and backport all the fixes from the latest version to the older versions also. But it's not always possible. The maintainability of the software is also there, and depends on how much support and maintenance you have for your software. If you're paying for the software, then you might get it. Even then, in such cases, sometimes the vendors force you to actually upgrade. For example, Kubernetes services. When you get a Kubernetes cluster as a service, sometimes the vendor is like, we can't support this Kubernetes version, so you have to or you must upgrade. We will force upgrade this. So before that, you better upgrade it in a smooth manner, right? And Kubernetes just keeps releasing newer versions and all, and there are many such softwares that just release a lot of versions often. So it's better to just be careful in such cases. There are a lot of softwares where the versions work very well and in a stable fashion, stable manner. For example, say Postgres, for example, it's well tested and it doesn't release too many new versions often and all, and it releases only when things are stable and all. They do the testing very well and whatnot, and they do releases of many versions like patch upgrades and all, the patch versions and all to do patch upgrades. And they also talk about how much time they will support it for, which is pretty important for any software to understand what is the end of life for support and maintenance, right? In terms of just the code, and if it's a service, software as a service, then you need to understand that also. So, and how it affects you. So, actually, in Capillary Technologies, they use Kubernetes. So, they were talking about how they do Kubernetes upgrades. They mentioned that all their clusters are on 1.331, which is, I think, the latest as of now. And they were talking about how they do Kafka upgrades, and they have Redis. I think they have MongoDB. I'm not sure if they have Redis or Valky too, but I think they have Redis, and it's okay to self-host Redis, I think. Only when you provide it as a service, I think it will go against and disobey the license of Redis, which is currently a source available license, and you cannot modify it and not distribute the modified version, and you can't just host it as a database as a service. And I think they might have more. I don't remember the other ones they mentioned, but yeah. For database like Postgres or something, they have, I think they use MySQL or Postgres. For that, they have Amazon Web Services, RDS. So, yeah, yep, right. Relational data system, I believe. Relational data system or service, one of those. So that they have delegated, but some of them they do run. They mentioned that this is critical and that's why they just delegated off. The others, I think it's less critical and accordingly, yeah. And for even Kubernetes, they use AKS, which is Amazon, sorry, EKS, which is Amazon Web Services, Elastic Kubernetes service, right? So yeah, and yeah, but I think they manage the worker nodes, so they still have to upgrade the worker nodes. And for the master, the control plane knows they can just upgrade it using the AWS console, I think, or the API, and yep. So these are some of the things that I missed to talk about. To tell that some things are important when you. It's important to do an upgrade and all that. And yeah, I also missed to talk about this, which I told Pallav, but I didn't tell you folks about what are the different things that I told him. And there was one more thing that I missed, I think. So in Srijit's conversation, this thing came up where he was asking me about networking, right? So this was in the second round. So just a moment. And he was asking me, is the database available to everyone? How do you host it and all? I told him about private networking, uh, and I told him that database will be available uh, only to the microservice that needs it, right? In terms of network uh, rules or like firewall rules, right? This is for both security and reducing possible errors. So usually the popular idea is that every microservice will have its own database and no other microservice database or databases whatever, and no other microservice will contact that database, only that microservice. So it doesn't make sense for multiple microservices to contact the same database. And I'm still writing it, but so yeah, at least this is what I've learned. And microservices talk through their APIs, HTTP APIs or whatever APIs they have, and don't talk to the some other entities or some other microservices database directly. Because at the database layer, you will not have a lot of um, what do you say, a lot of checks and other stuff happening, which is done at the microservice layer, and database layer is just pure data. A lot of logic will actually be there in microservice, and database will only have data related logic to ensure that the data is actually clean, without null values and stuff like that, and is like correct in the sense that the data type of the values are right. So, so I was talking about that, and I told that this will help with like blast radius in case, let's say, one microservice gets compromised, then it can't access the database of other microservices. It can only access the database of its own, so only its own database. This is in terms of like security. Let's say someone got access to the microservice, the host where it's running and all, and it cannot access other databases or other things. It can only access things that it should be accessing. And this also helps with ensuring the correctness and reducing possible errors. For example, a developer gives the host of some other database in the configuration of some microservice and gives the wrong configuration for the database host. But as in, it shouldn't be the one that they give, but they gave it some other microservices database with correct credentials and all for authentication and authorization, then it'll cause problems. It should not work in that case. At network level, they should stop it, or basically through firewall rules, or at the database level, they should stop it to understand based on what is the entity, the source, the client that's connecting, and based on that, the database should allow or disallow, like IP or something like that, some role or whatever, right? So, but yeah, I mean, if the credentials that the microservice has is appropriate, then it's going to be hard. Um, yeah, if you do that, that way you will ensure that the microservice is connecting to the right set of entities, microservices, and databases. And if they want to connect to the database, some new one, then they'll have to ensure that that change is also happening at the infrastructure level, or the infrastructure layer, so that it's explicit that this microservice now can access this other microservice and all that. And yeah, I mean, these are some of the things that I spoke to him, to Srijit, and yeah, and I think it's one of the rounds. I can't recall which one. I'm guessing it's Srijit's round or Deepak's round, where we spoke about storing logs, and I told him that, or even Pallav also. I told them that I've used but not built Elasticsearch, Logstash, Elasticsearch, Logstash, Kibana. I've used this. I told him, and I told them, like, in Grafana, I mentioned I've used Loki for log storage and indexing, uh, and log archival, right? I think Palla was also asking about this, and used New Relic in one case, and then I told how in Togai we use vector, which is basically vector dot dep, and this is at Togai, this is at Togai, this is at Ola, and this is at ThoughtWorks in Gojek, and I've also used GCP logs, Google Cloud Platform log service for Kubernetes pod logs and Kubernetes control plane logs. Right, pod logs basically worker load or workload logs, uh, and how do people view logs and whatnot. Viewing logs, storing old logs in a different manner, separately. All right. So this one came up, I think, even in Deepak's discussion. I told him that we can probably push it off to S3 or something. Because I told him initially the CI/CD system for that round, CI/CD system can just get the logs from the pods, but then if Kubernetes pod logs are gone from Kubernetes, then we need to actually keep it somewhere before it's gone. So we need to probably keep it in some storage like S3 or something similar, and then be able to show it to the user through a user interface. So these are some of the things that I spoke about. If I missed something, I'll talk about it in a separate video. So that's all I had for this video. I'll see you on the next one. Bye bye.